Okay, so I've been giving you equations like this and asking you to solve by graphing. Now that works if you get nice whole numbers. For example, the ones that we did at the beginning of class today, here, they intersect at 1, 1, 1, -2, etc. But what happens if they intersect like in the middle? You can't guesstimate what that is, like 1.2 or whatever. You can't guesstimate that. So you have to be able to do it using algebra. And that's what we're going to do right now. Here's the equation. X plus 4y is equal to 17. 2x minus y is equal to 7. So the first thing you do is pick a variable to solve for in either equation. Okay, it doesn't matter what the variable is, it's your choice. So you can solve for x or y in either equation. Now, make your life easier. What would be the easiest variable to solve for in the first equation? X or y? Yx. Or why would x be the easiest? Because it has a coefficient of 1. As soon as I move the 4y over, I have x equals. If I try to solve for the y in the first equation, what's going to happen is I'm going to move the x over, and then what do I need to do to solve for y? You'd have to divide off the 4, right? Which is going to generate fractions or decimals, etc. But if I choose to solve the x, all I have to do is move the 4y over, and I'll get x is equal to 17 minus 4y. Does everybody understand how I did that? All I did was add 4 or subtract 4y from either side. You want to solve for a variable that has a 1 in front of it. Okay? That's your whole goal. Then you have your other equation, which is, I'm going to do this in red. So now I have this equation and I have this equation. All right? This is just this. If you have two unknowns or two variables, x and y, you need two equations to solve them. If you have three unknowns, you need three equations. If you have four unknowns, you need four equations. However many variables you have, that's how many equations you need to solve. We only deal with two equations at a time. If you go on to university, you'll solve ones that have an infinite number of equations or variables. Okay? But we are just starting with two. So we'll always have two equations. The whole purpose of this method that you're going to learn, called substitution, is to make one equation with one variable. That's your whole goal here. So the fact that we solve for x here means that x is, equals means is, 17 minus 4y. So what I want to do with that is you want to take this and substitute it in, hence the name substitution, the other equation for x. So then what happens is this equation becomes 2, and where the x was, that is now 17 minus 4y. And then there's this negative y here. Did that make sense? All I did, so it's the same equation, this bit here is x. Okay? That's the only difference. I want to get rid of the x's. Now, I have one equation that's all y's. So we have to collect our y's. So the first thing, well, what would be my next step? What would I do? Get rid of the brackets. So the 2 gets multiplied in here. 34 minus 8y minus y is equal to 7. What do I do now? What would we do in polynomials if you had multiple y's? Collect your like terms. What's negative 8y minus y? Nine y. Okay, how do I solve this from here? Move the 34 to the other side. What's 7 minus 34? Negative 27. And what's the final step to solve for y? Divide by negative 9. 27 divided by 9 is 3. So y equals 3. Am I done? What else do I need to solve for? X. How am I going to solve for x? Plug that y value, take this, and put it into this equation right here for y. So this can go right there. So I get x is equal to 17 minus 4. And instead of writing y, you write 3. What's 4 times 3? What's 17 minus 12? So now you have x is equal to 5 and y is equal to 3. And then generally you write the answer as an ordered pair. So x always comes first, 5 and 3. So if you sketched out those two graphs, they would intersect at the coordinates 5 and 3. That's what that's saying. Okay. All right. Does it matter what variable you pick to solve with first? So if I took this equation, we're going to do the exact same equations, and I solve for y here. How would I solve for y? What would I do in this simple equation right here? Add the y over and move the 7 over, right? So I'm going to get 2x minus 7 is equal to y. What do I do with that? I have my other equation, which is x plus 4y equals 17, this thing. So where do I substitute this? Once you've solved for something, you need to substitute it. Where am I going to put that? Where the y is in that equation, exactly, right there. So then you get x plus 4. And instead of writing y, you write 2x minus 7. And then you do the exact same thing. Expand the bracket. What's x plus 8x? 9x. Move the 28 over, so I get 17 plus 28. What's 17 plus 28? 45. So if you divide off the 9, you get x is equal to 5. Which matches the one up there. So we know we did it right, or we hope we did. And then how do I solve for y if I'm using this method? Put 5 in for x. So that goes, goes right there. So you get 2 times 5. So you get y is equal to 3. Which is the same stuff. So it doesn't matter which variable you solve for. The whole idea, though, is to pick the variable to solve for that has a 1 in front. Okay? Once you do that, you move something to the left to the right. You take that bit, you sub it into the other equation for the variable, and then you're going to expand and solve for whatever the variable is. Once you know that, you put it back into the other equation to get the other variable. Do you want me to do one more? Yeah. All right, let's do the one on the front page, actually. If you go to the very front page, this one right here. Let's solve this one. This is on the front page, or the first page, I should say. Right there, page, I don't know what it is. 465. Okay, you have two equations. What variable would be the easiest variable to solve for? X or Y? X, because, okay, do you want to solve for this X or this X? First one, this one? Okay, so what do I do? Okay, so by doing what? Minus the 2y? So I move the 2y over, right? So I get x is equal to 12 minus 2y. Okay, I've got that equation. What do I do with that? Where does it go? Into the other equation for x, right there. So instead of writing x, I write 12 minus 2y plus 3y is equal to 17. Collect your like terms. What's negative 2y plus 3y? That's just y. Then move the 12 over. So I get y is equal to 5. Correct? What do I do with that to solve for x? Put it into the other equation. So then I get x is equal to 12 minus 2 times 5. X is equal to 2. And so you write it as an ordered pair of 2 and 5. Okay? Pick a variable. Pick the one that has a coefficient of 1 in front of it. Solve for it. Plug that into the other equation. Solve that. And then take that answer and plug it into the original. Okay? I would like you to do questions 4A and B, please. Okay. So, we have these two equations, or system, this system. 4x plus 3y is equal to 0, 8x minus 9y is equal to 5. What's the difference between this and the stuff we were just doing? There's no real simple one. There's no variable with the 1 in front of it. Okay? So now you just have to pick a variable. It doesn't matter which one. Okay, so do you want to solve for x or y? X? I heard x first, sorry. Do you want to solve for x in the first equation or the second equation? First one. Okay, so we're going to solve for x here. So I'm going to take 4x plus 3y is equal to 0. And if I'm going to solve for x, I'm going to move the 3y to the other side. Okay? Negative 3y. Does everybody understand how I did that? I'm just picking a random variable. Now, I'm solving for x, so I need to divide off the 4. So I get x is equal to negative 3 over 4y. Okay, now, you can use decimals if you want. I don't care. Okay? So what is 3 divided by 4? 0.75. So this is the same as x is equal to negative 0.75y. All right. Where does that go? There's our other equation. So that has to go right in for x. So I get 8 times negative 0.75y minus 9y equals 5. What do I do now? Multiply the 8 in. What's 8 times negative 0.75? Anybody? 6. It's negative 6. So I get negative 6y minus 9y is equal to 5. What's negative 6 minus 9? Negative 15. What's my final step? Divide by negative 15. Now you could reduce that to negative 1/3. Or if you want to do the decimal, negative 0.3 repeating. Okay? Did that make sense to everybody? What do I do with the y? Put it right back there. So x is equal to, I'll just use the decimal. Well, that's negative. 0.25. So your answer is 0.25 and negative 0.3 repeating. All right. Are there any questions about that? It's the same process, except you don't get as nice a numbers. You'll get decimals because there's no variable or coefficient of 1 here. But it's the exact same process. Just pick a variable to solve for. All right, I got one more to do, and then we're done. This one. So 5 times 2a minus 3 plus b is equal to 5, and 6a minus 2 times b minus 4 is equal to 20. All right. These are more complicated equations. So what do you think we need to do first? Simplify them. So for both of them, you're going to clear out the brackets and collect your like terms. So the first one, I'm going to get 10a minus 15 plus b is equal to 5. And the second one, I'm going to get 6a minus 2b plus 8 is equal to 20. So the first one, I'm going to add 15 to each side. And I'll get 10a plus b is equal to 20. So there is one equation. Second one, subtract 8 and you get 12. There's my second equation. So now it's like the other stuff. We've simplified the equations, so then you look at them, and is there a variable that would be easy to solve for? B in the first one, right? Because it has a coefficient of 1. So this one right here. So I'm going to move the 10a over, and I'm going to get b is equal to 20 minus 10a. Where does that go now? Into the second equation for b. Right there. And then solve for a. So I get 26a, add 40. Equals 52, and then divide by 26. A is equal to 2. So where does that go to solve for b now? Back to there. So what does b equal? 0. So as the ordered pair, write it alphabetically, it's 2, 0. Okay, that's as complex as they'll get. You'll have to simplify the equations first, and then pick a variable to solve for, and then just solve it. Questions? All right. I would like you to do number 5 and 7. And you can now do the back of that sheet that you got at the beginning of class, because you can use substitution on it to solve the ones in the back. And I'll post the key in the classroom.
My dad's here to pick me up. I'll try and come to school, but if they don't let me, then I'll just come for
Just
test.
watch the videos.
Yeah.
Email me when you're going to come in for the test, or
Yes.
email me when you want to come in for the test. All right? Okay, if you've done those questions, I put the key to the back of this sheet that you got today in the classroom. So you can do those using substitution as well.